angry. Don't forget to put units. Stay hot. Put minutes and round to the nearest 100. So right there, that's 7. Candace. And I'll be saying this, to a lot of people, exact value means no decimals. So that is number 5. Here. So no decimals. We multiply that. 275 over 1/8 reduces to 55. 55 times 5 times 6, so 5 reduce 55. Chris. Well, I can't read your writing, so slide's asking. Let's see. Nine over 5. So 9 times this, 5 now. So we convert to the decimal last. So we can put over there. Well, 2 5 times 1 24. Brennan. Butter. This one. So it's about one that we have these two down here. Exact. I say it. There. Not good. Okay. 14 to the 100. So that is 14.037. So around that is okay. Red. John Pablo. That's right. Now, you divide by 5. I don't know if you hear 300. That's 2. 5, 506, 562, 655, 665. It's just 4.9 inches. So 20 degrees. So don't convert to decimal. So, 1 and 2 times 2 pi 1, 2 goes to 18, 9 times, that's just pi 9.
Okay, so we haven't really talked about this guy yet. It's in doing the homework. But this one we have talked about. So let's take a look at it. And we'll do another at the beginning of class on Monday. We'll do another warm up that is just like this. That is going to be just like your quiz, just like we did Monday before. So. Obviously, the box will be a little bit different. All right. Hopefully, everybody gets at least 6 out of the 18. Cosine is 7 over 25. So right here, don't get this wrong. 7 over 25, and this is 25 over 7. Because see, this is the reciprocal. And what I mean by the directions, make sure you put your answer in the given space when it's provided. That's what I'm talking about. I'm going to have this typed in on the quiz, and I want you to put your answer right where it says secant, sine, and cosine, because I've had the experience where students will just put 7 over 25 and not link it to anything. So what does that mean? 7 over 25 is with those 6 things. So do yourself an incredible huge favor and draw a bloody picture. Not a bloody one, but an actual freaking picture. Okay. Get a right triangle. There's my theta. You got cosine of 7, which is adjacent, over the hypotenuse, which is 25. Cosine theta 7 over the 25. That is adjacent over hypotenuse because of SOHCAHTOA. Cosine adjacent over hypotenuse. If you're going to figure out the other 4, you need Pythagorean theorem. You're going to have to label the missing side with something. I need a variable. I tend to call the horizontals x's, the verticals y's. The hypotenuse, I can call it anything I want, depending upon what I have. I'm just going to call it a z if it comes necessary, but this is a y. So y squared plus 7 squared is equal to 25 squared. Y squared plus 49 is equal to 625. Subtract 49 from both sides. Y squared is equal to 580. Thank you. Don't know why I got stuck on that. I know the answer, but I didn't get my brain wrong. Take the square root and you get 24. Oh, it's a nice integer. That means this must be one of the Pythagorean triples that the bald guy in the front of the room was talking about the other day. Ah. Do as I say, not as I do. Don't you love it when adults use that phrase? I've been your age, you haven't been mine. That just means don't mess up like I have. So I can't write in pockets. Pythagorean triples. When it comes up to nice integers, those are Pythagorean triples. 7, 24, 25, always gonna make a right triangle. Okay? I don't know if any of you have actually Googled that yet. But that's something. Maybe you've Yahooed it. Okay. Or any of the other old search engines. Sine, opposite over hypotenuse. So now you just go 24 over 5. Cosecant with over 25 over 24. Tangent, opposite over adjacent. 24 over 7. Cotangent, reciprocal tangent, 7 over 24. There's 18 points. Okay. Cool. Any questions? Now, for right now, it's in a right triangle, which means the lengths of the three sides will always be positive because it's a nice right triangle all the time. When we do 5.3, you're going to get positives and negatives. You're not going to have positive and negative lengths, but because of where the angle terminates, is it in the first quadrant, second quadrant, third quadrant, fourth quadrant, we're going to have pluses and minuses to worry about. And I'll tell you right now, the mistake that people make is they don't draw a picture in the right quadrant, so they don't know what sign to put with those 6 answers. And that's where they miss out on all the points. Take care of your signs because you know where it is. Okay? Just a little foreshadowing. All right. Calculator time. If you've noticed on a calculator, if you have it, yeah. But on a calculator, the 3 trig functions you have are taking the sine of an angle, the cosine of an angle, and the tangent of an angle. There ain't no secant button. There ain't no cosecant button, and there ain't no cotangent button. There isn't. Sorry, there isn't any. Right above, it says sine with a -1, cosine with a -1, tangent with a -1. That's not an exponent. It is not a power. It's the inverse notation. Sine -1 of, well, let's just go 1/2. This is the, in other words, also known as the arcsine of 1/2. It's the inverse trig function, the inverse sine button. When you learn how to, when we teach math to you guys, from first grade, kindergarten on, we teach you how to add. The next thing, subtract, multiply. Now we're going to undo it, go the other, divide. Teach you how to square a number, here comes the square root. Teach you how to use exponents. Here it comes, we've got to undo the exponential function, logarithms. trig functions, you're going to take the sine of an angle. You're going to take the sine of 30 degrees. The sine of 30 degrees is always 1/2. So now what do you do if you have a 1/2? In other words, the sine of what angle I want to know is equal to 1/2. How do you undo the sine of something? I want to solve for theta that's in here. Over here, you're given theta. So you're going to figure out the ratio. What's the answer? Inverse trig functions take the answer, the inverse sine of 1/2, and it turns it into the theta. It undoes what the sine did. That's what inverse functions do. That's what these buttons are. They're not negative powers where you flip it. So that's not the cosecant button. That's not the secant. That's not the cotangent. It's not going to flip it for you. Okay. If I press inverse sine of 1/2, it'll give me 30. As long as my calculator is in degree mode. If it's not in degree mode, then it'd be in radians. If it's in radian mode, it's going to give me pi over 6. As 30 degrees is the same as pi over 6, which is what we're going to cover when we get to 5.3. So you don't have a secant button. There's not a secant button. But you have to take the secant of 76 degrees, 42 minutes. The first thing I'm going to do is make sure my calculator is in degrees. If this whole thing's going to fall apart at the time. Mode, and I'm in degrees, so I'm making sure degrees. All right, we're good to go. So remember what this secant is. Secant is the reciprocal of who? Cosine. Secant of theta is the reciprocal of cosine theta. So the secant of 76 degrees, 42 minutes, is 1 divided by the cosine of 76 degrees, 42 minutes. You have a cosine button, you don't have a secant button. So all I have to do is I'm going to take 1, I'm going to punch in the cosine of 76 degrees, 42 minutes. I'm going to get that down here. So cosine 76 degrees. So second, angle, hit the degree symbol, and then 42. I need minutes. So second, angle, and I hit the minutes, which is option 2. So cosine of 76 degrees, 42 minutes, that's close the parentheses, enter. And the cosine of 76 degrees, 42 minutes is 0.2300497372. Now, if you notice, the reason why I'm doing so many decimals is because it says round your answer to 6 decimal places. So I need as many decimals as I can in my answer, and then I'll round at the end. Okay. So now, again, this is my secant of 76 degrees, 42 minutes. You're not going to turn that in. How do you? That's not. You can't round that. It's not a decimal yet. So all you do is divide 1 divided by that number, 1, and then divide by the last answer in the calculator. 1 divided by, and then I hit second, the negative symbol. The negative symbol is the answer. So it's 1 divided by the last answer in the calculator. secant comes out to equal 73.42 minutes is 4.346886.079, and then round to 6 decimal places. That's right. 1, 2, 3, 4, 5, 6. That 0 leaves it a 6. 4.346886. You do the same thing if they ask you about cosecant of an angle. You do the same thing if they ask you about cotangent of an angle. It's 1 divided by the tangent of it, 1 divided by the sine of it. Okay. If the angle right here was written in radians, just make sure your calculator is in radians before you punch anything up. Any questions? That's what Monday's quiz looks like. And again, we'll do another one beginning of Monday. All right. We left off at one of the most important critical junctures in this class. We talked about them, now you're about to see. You need to know your special right triangle. So you need to know your special right triangles backwards, forwards, left and right, upside down. I don't know if you saw. Did you see Baymax with the, was it? Big Hero 6, yes. And the guy that wore his underwear backwards, frontward, sideways, and then inside out, like he got 6 days out of wearing his underwear. That's how you need to know special right triangles. Stanley played with that. Big Hero 6 is a marble problem, because everything's a marble problem, which means everything actually belongs to Mickey Mouse. You will be getting, after we finish, or in the middle, as we finish 5.3. You will be getting this. A nice color version of a complete unit circle. Now, we've already done the angles and the radius. 30 is pi over 6, 45, that's a quarter of pi, 60 is a third, 90 is pi over 2. We've already done the radian degree mix-ups all the way around. But the unit circle that we did was not on an XY axis. Now we're putting it on an XY axis. And again, this is foreshadowing 5.3. It'll be on an XY axis, which means you have ordered pairs on the unit circle. What makes it a unit circle is that the radius is 1 unit. The length of the radius is 1. So from the center to the circle, the ordered pair right there would be just 1, 0, because the radius is a 1. If you know that radius is a 1, you know the coordinates of all those special angles as you go around the circle. Here's all the coordinates as you go around the circle. Now, pointing out to you, pi over 6 and 30 degrees, the x is the square root 3 divided by 2, and the y is the 1/2. If you go to its buddy over here in quadrant 2, because, and again, foreshadow, this is 30 degrees of opening from the x-axis at 150, 5 pi over 6, 1 pi over 6. This is 30 degrees of opening from the x-axis. When you have the same amount of opening from the x-axis, I'm not trying to fly, but from the x-axis, you are a reference angle. The reference angle is 30 degrees. Since this is 30 from here, from the x-axis to here, your reference referring back to quadrant 1 is 30. This is 60 degrees. From this x-axis to the 120, that's a 60-degree angle. So the reference back in quadrant 1 is 60 degrees. Right here, it's 45 degrees to 225. So the reference angle in quadrant 1, referring back to, it's 45 degrees in quadrant 1. Right here, this is 60 degrees from the x-axis. So from the x-axis, the reference angle is the 60-degree angle up in quadrant 1. And here's y. 30 and the 30. That's a root 3 over 2. That's a 1/2. Over here, it's a negative root 3 over 2 and a 1/2. The values are the same, just they have a different sign. And the reason why you have a different sign is because when you go to the left, x is negative, and we go up, y is positive. But the ordered pairs are the same number, 3 over 2 and a 1/2. When you go into quadrant 3, 30 degrees at 210, 7 the x and the y, root 3 over 2, 1/2, root 3 over 2, 1/2. That is a reference angle of 30, which means it's the same numbers, but in quadrant 3, x is negative, y is negative. They're just negative values. They would just be the negative coordinates of what you see in quadrant 1. And if you're in quadrant 4, 30 degrees, x is positive, but y is negative. It's the same two numbers, root 3 over 2, 1/2. But the x would be the same because it's to the right. Y would be the opposite because you have to go down. It repeats all around the circle based on the reference angle. So here's the deal. It looks like a lot, but it's all about quadrant 1. It's the same numbers all around the circle, but it's all back to quadrant 1. It's all back to 0, 30, 45, 60, and 90. If you know those, you know everything. Okay, so I'm trying to, again, it's not pi 3 yet today, but it's foreshadowing. I'm trying to ease the anxiety of trying not to memorize, try to think it through. And for me, thinking it through, I'm visual. I have to see a picture. I draw lots of little sketches that help me put the pieces together. Okay, I will talk you through it. I will help you through it. I'll show you, but I just don't go straight to here's the equation, here's how you do it, without seeing what's going on. But before we can complete the unit circle as it actually looks like complete, before I can give you that precious little gift, we actually have to do these. You are going to need to know by heart the answers for sine, cosine, tangent of 30 degrees, 45 degrees, 60 degrees. And hopefully you're going to know when we get to the unit circle. It's not unit circle, time unit. you'll know 0 degrees, 90 degrees. After that, it's all about repetition. So right now, we're going to do the sine of 30 degrees, the cosine of 30 degrees, the tangent of 30 degrees. And then obviously, if you know those, you know the cosecant of 30 degrees, you know the secant of 30 degrees, and you know the cotangent of 30 degrees. Okay. The sine of 30. You know, back in the old days, when you wanted the sine of 30 degrees, or you wanted the sine of 37 degrees, you would have to go into the back of a textbook, and there would be a table of values. Usually rounded to 4 decimal places. If you had a really good textbook, going out to like 6 or 8 decimal places. But somebody figured out all the ratios for a whole bunch of angles. Some even did it in degrees, minutes, and seconds. You know, the tale is there's a whole bunch of monks, centuries and centuries, writing down all these ratios for 31, 32, 33, 34, and then 31 degrees, 1 minute, 1 second, 31 degrees, 2 minutes, you know, so on, all the way. Which means if you could write it in a table, that table is never going to change. It's always these answers. The sine of 30 is not going to change no matter how big the circle is that you draw, no matter how big the triangle is, little triangle, big triangle, because the ratios have to stay the same. The sine of 30 degrees is 1/2. That'll be 1/2. The cosine of 30 degrees is going to be square root 3 over 2, always. And the tangent of 30 degrees is going to be, now, here's what I hope you just leave it. 1 over square root of 3. But when you look at the back of the book, they're always going to rationalize, you know, improper fractions like this. Or denominators that are irrational. So in the back of the book, and even on the unit circle, is going to look like square root 3 over 3 when you rationalize it. I'll take either one. I'm telling you, you don't have to rationalize when you write it as an answer. Okay? Correct. Now here's why. If you start with an equilateral triangle, an equilateral triangle is a triangle that has 3 equal sides. And I believe I've already actually talked about this. Got 3 equal sides. If all 3 sides are equal, all 3 angles must be equal. Since the 3 angles add up to 180, 180 divided by 3 gives you 60 degrees at each vertex. Okay, this is always true. Now, the last time I believe I did in this class, for convenience sake, I called each side a 2x. This time, I'm just going to call it x. I could actually think of a number, you know, put like a 10 right here, so they'd all be 10s, and then figure out that the ratio is still going to be 1/2 when I do this. But what if that only works if it's a 10? Then I try 12. Well, what if it's only 10 and 12? Then I try 18. What if it's only 18, 10, and 12? What you need to do when you say always, you need to show that it works for any number x. So that's an x, that's an x, that's an x. Okay. The next thing that happens is we draw the perpendicular bisector from this vertex to the opposite side. So a perpendicular bisector is perpendicular to the opposite side, and it bisects the opposite side into two equal pieces. If the whole thing was X, then how big is each piece? Half of it, X over 2. Those two pieces are now X over 2s. Now, the reason why I did that is because I'm supposed to be working with a 30, 60, 90 triangle. Well, when you draw that perpendicular bisector, you create two congruent triangles. They're congruent because you have a side congruent to a side, angle congruent to an angle, and this side would be congruent to itself. Because of side, angle, side, you have two congruent triangles left and right. You see, in math, you can't just assume stuff. It has to be proven true. You have two congruent triangles. And if the two triangles are congruent, all the corresponding parts must be congruent. CP, corresponding parts of congruent triangles are congruent. Okay, I haven't taught geometry since like 1993. I still remember this stuff. Only class I got an A in college. Only math class. Yeah. And we did proofs that were like, 90 steps long. Man, makes sense. Okay. So these two have to be equal. If it was 60, 30 degrees. 30 degrees. Dr. Zane, professor, his hands were all like, I don't know if he was like a, a middleweight boxer growing up, because his hands were all just gnarly and stuff. Like hold the pen, back then was chalk. Back then we wrote on the back of like snow shovels, coal, with our advocates. Drafting out. Oh, I paid $10. Give my money back. There. So we know this is X, half of X. We just got to figure out the missing piece. So I'm going to, don't need the whole equilateral triangle anymore. I'm going to take this one on the right. I'm going to take it out of the picture, and I'm just going to flip it over. So the 30 degrees is here. Just putting it on its side. So take this, rotating it, putting it over here. Now, the hypotenuse is X. And opposite 30 is X over 2. And we just don't know this missing side right here. Since I'm already using X's over there, I'm just going to call this, let's call it B for right now. Put on A squared plus B squared equals C squared. So to figure it out, put that right there. B squared plus X over 2 squared equals X squared. Length squared plus length squared equals hypotenuse squared. So B squared plus X over 2, the whole thing squared, is X squared over 4 equals X squared. So when I solve for B squared, I got to subtract X squared over 4 from both sides. So B squared is equal to, what would X squared minus a fourth of an X squared? What would one whole X squared take away a fourth of an X squared? What? Fractions.
Oh, no.
Yeah, 3. Let's just say, what do you, if you have $1 and you take away a quarter, how much do you got in fractions? take away 1/4, how much do you have left? 3. You're answering the question from 8 minutes ago. You have $1 and we take away 1/4. What do you have left? 3/4. 3/4. 3/4. Yeah. I didn't need the x squared. So 1x squared, take away 1/4 of the x squared, leaves 3/4 of the x squared. Or 3x squared over 4. Okay, everybody all right? Do left, it's right. Solve for b, take square root. Square root the whole thing. Now look what you can do with a radical. This is for a fraction. The square root of 3x squared in the numerator, square root 4 in the denominator. In the numerator, you want to take out any perfect squares. Well, the square root of 3 is not breaking out of that square root, but the square root of x squared is just x. So this is going to equal x times the square root of 3, and then square root of 2. So this is square root 3 over 2 times the x. This one is always 1/2 times the x. In a 30, 60, 90 triangle, the hypotenuse, whatever it is, no matter what, the short leg is always half of the hypotenuse. Or the hypotenuse is twice the short leg. Why is that the short leg? It's opposite the smallest angle. Shortest leg is opposite smallest angle. The short leg, half of the hypotenuse, or you could say the hypotenuse is twice the short leg. So if I use, let's use A, if the short leg is an A, then the hypotenuse would be 2 times A, twice as big. The long leg, opposite 60 degrees, is square root 3 over 2 times x times the hypotenuse. Or that's 1/2. This is square root 3 times x 1/2 x. This can be written as a square root of 3 times a 1/2 x. It's square root 3 times that short leg. It's just square root 3 bigger. And you better make sure that you get the longer leg bigger than the shorter leg. So you multiply by square root 3, which is 1.732. It makes that last answer bigger than the first answer. So if that's the short leg, the longer leg is square root 3 times the A. Or I would put the A in front because that's the one I get it confused. A times square root 3. In a 30, 60, 90, that is always true. No matter how big or how small you draw a 30, 60, 90 triangle, those are the ratios of the sides if the angles are at 30, 60, 90. Always. So when we take the sine of 30, take the sine of 30 right here, the opposite 1/2 x divided by the hypotenuse, which is x. X over x reduces, I get the sine of 30 degrees is 1/2. The x's don't matter. even if I wrote it up there, the sine of 30 degrees, if I use this rendition, the opposite is A, the hypotenuse is 2 times A. So the sine of 30 degrees is always A goes into A once, A goes into A once. The sine of 30 degrees in this picture is 1/2, 1/2. It doesn't matter. The sine of 30 degrees is always 1/2. And if you have a 1/2, what's the sign going to be? It always goes with sine of 30 degrees. It's also the sine of pi/6 radians. Because pi/6 and 1/2 are buddies. Pi/6 in radian is the same as 30 in degrees. So if you take the sine of pi/6 in radians, you get a 1/2. Okay. The cosine of 30 is the adjacent square root 3/2 x divided by the hypotenuse, which is x. And those x's reduce. So you get a cosine of 30 degrees is always square root 3/2. Always. You deal with that one? Cosine 30 degrees, adjacent A square root 3, hypotenuse 2 times A. The A's reduce. The cosine of 30 degrees, you're left with square root 3/2. Done that. Square root 3/2, which means that goes for radians. The cosine of pi/6 is square root 3/2, always. And then tangent. Well, tangent, you can put sine over cosine. Okay, so if you know the cosine, you know the sine, you can just put one over the other. The tangent of 30 degrees would be the sine of 30 degrees divided by the cosine. That's one way to do it. So if I actually did it this way, because I have those other answers, the cosine is square root 3/2, and the sine is 1/2. Now remember, when you take a fraction and divide by another fraction, this is what's going on. If you actually write it out literally, it's the numerator square root 3/2, and it's being divided by the denominator, which is 1/2. Okay. I wrote it upside down. Idiot. It's not sine over cosine over sine. Idiot. Cosine 30 over sine. So that's cosine square root 3/2. And you're dividing by 1/2. Again, I wrote it back. Okay, time out. Sine over cosine, sine over cosine, sine. I should have just done opposite over adjacent. Sine over cosine. Sine 30 over cosine 30. I don't know what my brain. I told the first class, because I made a mistake during the first class. I said, all right, maybe I should start the class later, and my brain would be a lot, fresh if I just start a little bit later. Then I thought, no, wait a second. The later the day it gets, the worse my brain gets. I actually get worse than I am right now. Not a good idea. My apologies. 1/2. There we go. Over square root 3 over 2. So it's that 1/2 being divided by the square root 3 over the 2. Which means the tangent of the third is equal to the 1/2 times the 2 over the square root of 3. So now your 2's reduce. So the tangent of 30 degrees is 1 times 1 over 1 times square root 3. 1 over square root. Sine over cosine. But you could also opposite 1/2 x over adjacent square root 3 over 2x. Again, the x is reduced. 1/2 divided by square root 3 over 2. Well, 1/2 divided by square root 3 over 2, we just saw 1 over square root 3. Okay. What's really nice is when you have this rendition, because now your tangent of 30 is a over a square root 3, 1 over square root 3. Okay. Reciprocal functions. Well, if you know these, you know those. You flip over sine or cosecant 30. Now, this will be marked wrong. Or this will be, you'll have a point taken off. The reciprocal of 1/2, yes, I know, is 2 over 1. The directions always stay simplified. What's 2 divided by 1? Just 2. If you put 2 over 1, that's not simplified. Okay? The reciprocal of root 3 over 2 is just 2 over square root 3. Again, you don't have to rationalize it. Just leave it like that. If you do rationalize it, you would get 2 square root 3 over 3. But just, you're good to go, 2 over root 3. And that cotangent, that's why it's nice to not have to worry about rationalizing everything. 1 over square root 3, if you flip this over, it's just square root 3. I know the reciprocal is 1 over, or square root 3 over 1, but again, square root 3 divided by 1 is just square root 3. Now, here's the dilemma when you get into this unrationalizing mode. So let's say you take your tangent 30 degrees and you go, all right, I'm going to rationalize, so square root 3 over 3. So now your cotangent 30, you take the reciprocal and you put 3 over square root 3. Well, if you're going to rationalize 1, aren't you, technically setting the precedent you better rationalize all the time? So then now you got to worry about trying to rationalize this, square root 3, square root 3, 3 square root 3 over 3. Those reduce, so your cotangent of 30 degrees is just a square root 3. What I'm worried about is you have the right answer, then you do the extra work to try to rationalize it, and you get a right answer, and because you're trying to hurry, you make it into a wrong answer. Okay? So you don't have it. So that's our rules for the 30, 60, 90. So if we know 30, we know it all. And that's the point. If we know 30, you know everything about 30, 60, 120, 150, 240, or sorry, 210, 240, 300, and 330. You know all of the 30 multiples of 30 around the circle, except for the 90, 180, and 7. Because those are special. They're on the active. The 30, 60, 90. Then the 45s. 45s go quicker. Nice thing about 45, isosceles. Wanted to name my son isosceles, the wife wouldn't. Then I wanted to name my daughter isosceles. She didn't have any. Sometimes I think I need to check the measure. I just need to get my money back from those improv classes. If it's isosceles, then if this is X, that must be X as well. Now, if those two are X's, what is the hypotenuse? I'm going to call it Z for right now. So Pythagorean theorem. X squared plus X squared is equal to Z squared. So that's two X squareds that add up to a Z squared. And you take the square root of both sides. And so the hypotenuse Z is equal to, simplify the square root. And the square root of the X squared, you can take out an X, but the 2 stays inside the radical. So it's X times the square root of 2. So the hypotenuse in a 45, 45, 90 is always the leg times the square root 2 bigger. It's always a leg times the square root 2. All. So sine 45, it doesn't matter which one you pick, sine opposite over hypotenuse, x over the hypotenuse, which is x squared 2. If you use this 45, opposite is x, and hypotenuse is still x squared 2. You're going to get the same ratio. The x's reduce, which means it doesn't matter how big you make this 45, 45, 90. These are the ratios of the sides all the time. So 1 over square root 2. 1 over square root 2. Again, if you rationalize it, this would be square root 2 over 2. And just as a side note, because I'm going to do a comparison here in a second, we ended up with the sine of 30 is always 1/2. Cosine of 30 is square root 3 over 2. Tangent 30 is 1 over square root 3. I'm just going to write those on the side so keep track. Just those. If we know those three, you know the reciprocals. Just those. Cosine, well, the cosine of 45 is adjacent over hypotenuse. Well, guess what? If you know sine, you know cosine because they're going to be equal to each other. It's the same angle. It's isosceles. 1 over square root 2, which is square root 2 equal. Okay. Tangent. Opposite over adjacent, so opposite 45 is that x, adjacent is this x divided by x, 1. Because it's isosceles, opposite leg and adjacent leg are equal to each other. It's isosceles. Always going to be a 1. No matter what. So those are the always answers for the 45, 45, 90 special triangle. Sine, cosine, tangent. And therefore, you're going to know the reciprocals. Now, for the reciprocal, look how nicer it is to flip over this answer. 1 over square root 2 is just square root 2. That's the cosecant of 45. Again, if you put square root 2 over 1, that's not simplified. If you flip over square root 2 over 2, well, that works. 2 over square root 2, yeah. But if you rationalize this one, why aren't you rationalizing this? So that's 2 square root 2, and then down below, square root 2 times square root 2. That's a 2, and that reduces to just square root 2 anyway. But they're the same thing. Okay. Same thing here. Square root 2 or 2 over square root 2. And hey, what's the reciprocal 1? What? I had that there. And last but not least, the last more special angle will be the 60. So we're going to call up our 30, 60, 90 one more time. But this time, right here, this is our 60. 60 degrees is here, 30 degrees is up there, there's our 90. And instead of using the 1 or the x as our hypotenuse, we'll make it 2. This is a 2a. The short leg is half of the hypotenuse, or the hypotenuse is twice the short leg. This is 1a. And the long leg is square root 3 times the short leg. So if this is a, this is a times square root 3. And that's the key. The hypotenuse is twice the short leg. It's all about the short leg. The hypotenuse is twice the short leg, and the long leg is square root 3 times the short leg. Okay, so it's all about going through the short leg. It's not real simple to just go from hypotenuse to long leg. You want to go through the short leg. Okay. So sine of 60. Opposite, a squared 3 over hypotenuse is 2a. The a is reduced, square root 3 divided by 2. Cosine of 60. Adjacent over hypotenuse. So adjacent is a. Hypotenuse is 2a. Again, the a is reduced. So that's a 1 over 2. and tangent of 60. Opposite over adjacent. So a squared root 3 adjacent is a. The a is reduced. Square root 3 over 1 is just square root 3. And then do your reciprocal thing. This would be 2 over the square root of 3, or 2 square root of 3 over 3 if you rationalize. The reciprocal of 1/2 is just a 2. And the reciprocal of square root 3 is 1 over square root 3, or square root 3 over 3 if you rationalize. Now, 30 degrees and 60 degrees exist in the same triangle. They exist in the same triangle. The sine of one angle, the sine of 30, is the cosine, the same thing, of 60. They're both 1/2. The cosine of 30 is exactly the same as the sine of 60. They're both square root 3 over 2's. And the tangent of 30 and the tangent of 60, well, they seem to be reciprocals of each other. Now, that has nothing to do with these guys over here because 45 is not in that triangle. But what's the connection between the 30 and the 60? It's a word we actually came across in 501. I'm making faces behind this math. You know, there used to be prerequisites for class. I think I'm going to have to put one in for like sense of humor. I don't know. Or maybe I just need to figure out what I want. I mean, I don't, you can grow. You can throw a shoe at me or something, man. Just tell me to get a day job. I don't care what, but just at least let me know that you're alive up there. Okay. I don't need you to laugh. I just need to know that you're alive. I can't even hear you breathe. Right. There used to be one guy way back when I was maybe teaching night classes. He would always sit in the back, took his chair over, and then one all the way to the front of the room, all the way to the front of the room. I used to raise guide dogs, so I used to bring my dog Wrigley. He was in front of my dog Wrigley. And then do that running thing when dogs run and sleep and it was good. So I didn't know if it was Wrigley smart or the guy in the back. Everybody in the class is just laughed. But I taught if you can, we always try when somebody feels tough, try to sneak out. And then call the classroom, ring the telephone, and the guy wakes up or whoever wakes up, and there's nobody left. Complementary angles, their sine is this, two complementary angles. One sine is the same as the cosine. So one angle's complement, their sine cosine have to be equal. The cosine sine would be the same, tangent cotangent. Now, they're not equal, they're reciprocals, because here's the deal. 30 degrees, the sine of 30 is opposite over hypotenuse. Well, opposite is 60 adjacent. The opposite of 30 is 60 adjacent. Adjacent over hypotenuse is cosine for 60. So one angle's sine is the complementary angle's cosine all the time. If we just generalize this, and you see it, If we label a triangle, let's go PQR. So PQR. So there's a little P, there's a little Q right there, there's a little R right here. And so let's compare the sine of angle P, that's the cosine of angle P, the tangent of angle P, the sine of angle R, the cosine of angle R, and the tangent of angle R. The sine of P is the yellow stain on your pants. Okay, good. Okay. That was horrible. But I went for it anyway. The sine of angle P is lowercase p over q. The cosine of angle P would be lowercase r over p. And the tangent for angle P would be lowercase p over r. The sine of angle R, opposite over hypotenuse, so lowercase r over q. The cosine, adjacent, lowercase p over q. And the tangent, opposite over adjacent, would be lowercase r over p. Now, because this is a right triangle, and I put right angle, angle P and angle R have to add up to the other 90 degrees. They have to, no matter what. Maybe this is 20, so that has to be 70. Maybe this is 78, so this has to be 12. No matter what, they have to be complementary because one angle is 90. They always are going to be complementary. So the complementary angles, one side is the complement's cosine, and vice versa. Cosine, sine. Tangents are reciprocals of each other. Because angles P, opposite over adjacent, is angle R's, okay, adjacent over opposite. Things that just make sense. Pieces of a puzzle to put together. So when we go back to this one, and it looks like there's so much. "30 degrees. The x coordinate, because you're going to make, and again, this is perfectly fine to just give you this little glimpse into Monday. Right here at this 30-degree angle, you're going to be able to make a triangle in the picture. That's why the ordered pair right here, this is the 30, this is the short leg. If the radius is 1, the short leg is half as big, and the long leg is square root 3 times that short leg. So square root 3 times 1/2 is square root 3 over 2. So the x coordinate, square root 3 over 2, and the y coordinate is the 1/2. And then when you get to the 60-degree angle, now this is 60. So this is now your short leg. The radius is still 1. This is your short leg. So this is now your 1/2. This is the long leg right here. So this is now your square root 3 over 2. So up here, the x is a 1/2 and the y is square root 3 over 2. If I know one of them, I know every one of them. And I'll be honest, I only know one of them. I know by heart at 30 degrees, the sine of 30 is 1/2. 30 is a small angle. It's the smallest out of all the ones you're supposed to know by heart. I'm not talking about zero. Yeah, zero is different. But 30 is the smallest one. So it's got the smallest answer for sine, 1/2. As you go up around the circle, the y's get bigger because right here, y is a 0. But as you go around the circle, that's the y, then there's your y, then there's your y. Then up here, that's the biggest y you're going to get, 1. The smallest y is a 1/2. This is bigger. Square root 2 divided by 2 is approximately 0.707. And then square root 3 divided by 2 is approximately 0.8663, I think, or 0.8661 or 0 something. But the y gets bigger. The bigger the angle, the y gets bigger. And then at 90, the y is 1. Okay? I know sine of 30 is 1/2. So if sine of 30 is 1/2, cosine must be the other guy. Oh, root 3 over 2. If I know one, I know the other. Because 1/2 and root 3 over 2, they go together. And then how hard is it for 45? 45 degrees is isosceles, which means 2 equal sides. That's the one that uses the square root of 2 over 2. All your 45 degrees, root 2 over 2. Or 1 over root 2 if you're not going to rationalize. Okay. You've got to find a way to know, again, not necessarily memorize all 4 quadrants. If you know quadrant 1, you have everything. No. Now we've talked about 30, 60, 45. Just a quick, before we go back to the homework. Right here in my picture. What about, and actually I want to get, I'm going to go back to triangle PQR. What this? We've done the 2 complementary angles, but we haven't actually done the right angle. We haven't done the 90-degree angle in the triangle. There's a reason we haven't done it. So if we do the sine of angle Q, opposite over hypotenuse, this technically actually does come out to the right answer, but it's not, I don't recommend this. Opposite Q is Q. The hypotenuse is also Q. The sine of that 90-degree angle is 1. And that's true. Sine of 90 is always 1. It is going to be 1. But not because of that. Cosine. Now you want adjacent over the hypotenuse. So you know down here is Q. So pick the adjacent side to angle Q. Is it R or is it P? Is it P or is it R? Remember, they're not the same length. If you pick P over Q, that's a different answer than R over Q. That's why you cannot do this right now. You can't do it. Likewise, if you try to do tangent, opposite over adjacent, well, opposite is Q. But again, which one's your adjacent? Is it the P or is it the R? Because they're both adjacent technically. Angle Q. So you can't decide, therefore you shouldn't decide, don't do it. We don't do sine, cosine, tangent of 90 degrees using triangles. Because if your angle is 90 degrees, you don't have necessarily a triangle. Okay? Because the angle that you're making out is, for the all intents and purposes, has to be one of the complementary angles. That means the complement to 90 would be 0, and if the other angle is 0, you ain't got triangle. So only for acute angles in the right triangle do we do SOHCAHTOA. So on Monday, there's a different method. So we can handle all the quadrants, and you'll get pluses and minuses to go along with it. Now back to the homework. They're filling in this table. 21. Construct an appropriate triangle to complete the table. So they actually want you to draw a picture. Find the sine, the angle's 30 degrees, convert it into radians. So 30 in radians, 5 6. And then what is the sine of 30 or the sine of 5 6? That's what they want here. So if you construct a triangle, then you're looking at something that looks like 30. Yeah, we just did all that. You should know. That's going to be A, that's 2 times A, that's A squared 3, opposite over hypotenuse. You can just put 1/2. I'm fine with that. Okay, because that's why we did all that work. That's why I took the time to do all that work. That's why I wrote all this down, so you can start knowing it. Let's say memorize, start knowing it. This is your life. Okay. Cosine of 60 in radians, that's pi over 3. So the cosine of 60 is square root of 3 over 2. And then, now they want tangent of, and they give you the radian. So now you got to fill in the column that says, what's the degrees? Pi over 3 in degrees is, well, you put that in there. And the tangent of 60 is square root of 3. If I was doing number 24, okay, first of all, the secant pi over 4. 45, those are the 45-degree angles. We have quarters, you're dealing with quarters or 45-degree angles. So it's just one of those pi over 4, so it's 45 degrees. But here's the kicker, secant of that. My brain does not do secant, cosecant, or cotangent in my head. Again, the only one I know by heart really is my sine of 30 degrees. I know the 45 has square root 2 over 2 or 1 over square root 2. So I'm not going to try to think what is this, straight ahead, what is the secant of 45? Flip it. What's the cosine of 45? Well, 45, you have isosceles. That's where you use root 2 over 2 or 1 over root 2. So I'm going to think through the cosine of 45 is 1 over square root 2. So the secant is the reciprocal, just square root 2. Okay. And then I'm going to do 26. That'll help you do 25. Now you have the actual answer. They want to know what the angle is. Now, all our angles right now between 0 and 90. We're not going to the other quadrants. The answer for cotangent is square root 3 over 3. So you're supposed to figure out what theta is in degrees and then in radians. So technically what you have, if you wrote it as an equation, the cotangent of some angle theta gives you a ratio of square root 3 over 3. Square root 3 over 3 is one of our special angles, special ratios that gives us one of our special angles. 0, 30, 45, 60, or 90 theta. Well, we can rule out 0 and 90. We're going to talk about this yet. Square root 3 over 3. Well, only 45s use square root 2s or tangent is a 1 for 45. To rule that out. So it's either a 30 or a 60. So my brain does not do cotangent. Tangent. So tangent would be 3 over square root 3. My brain doesn't like that either, because it likes the nicer form. So this time I am going to rationalize and look at it a little nicer. Okay, this would be 3 square root 3 over 3, so it's just square root 3. Okay. As you go up and rotate from 0 going up. Remember what I showed you on the unit circle. The y's get larger on the unit circle, right? That angle at the origin, that's your theta. So the angle gets larger, the y's get larger. As the angle gets bigger, y's get bigger. The y is the opposite side. Now, as you go around the circle, the x right here is longer than the y. But as you open up a larger angle, the y is a longer side, the x is really short. So when you make the ratio for tangent, and you put tangent for theta is the opposite over the adjacent. As the angle gets bigger, this is a lot bigger, and this is a lot shorter. So let's just say really big, like a 10, over really short, like a 0.1. How many dimes go into a $10? 100. The tangent, in this case, the tangent of that angle theta would equal 100. As you get an angle closer to 90. When it's this way, the bottom is big. If the bottom is bigger than the top, then you're going to have an answer less than, really small. So square root 3 is a lot bigger than 1 over square root 3. That's what this is. So is it 30 or is it 60 if this tangent is square root 3 as you're going up? Tangent of 30 versus tangent of 60. Would it be tangent equal to a square root 3 if it's 30 degrees? Or if it's a tangent of a 60 degree? 60. Because square root 3 is bigger than this. Square root 3, 1.732. And then this is square root 3 divided by 2, smaller than this. Smaller than this. So at 30 degrees, the tangent is very small. And as it goes up, the y's get bigger, the x gets smaller. So it's going to start to be a lot bigger. Okay. So this is the bigger answer. So the bigger angle, 60. Oh, yeah. Tangent 30, 1 over 3. Tangent 60, there it is, right behind you. That's my 60. So this is 60, which means it's higher. Okay. Okay, 0.735. Okay, 27, 29, they are giving you the radians converted to degrees and then take the cosine of those things. And then here, looking at 29. The cotangent of some angle is a 1. The only time 1 ever happens in the acute angles. Okay, 45. For tangent, only time tangent equals 1 is when you get opposite and adjacent equal to each other. So it's got to be isosceles, 45, 45. So that means this is equal 5 degrees, which means powerful. And then you're going away 35. So here you're just punching it up on your calculator, just like the warm up. Okay. And for, be sure the calculator is in the correct angle mode. 31 degrees, D degrees. 33 degrees in minutes. Degrees, minutes, and seconds. And again, you don't have a secant or a cosecant button. So you're going to punch in, 1 divided by cosine of that. 1 divided by the sine of this. Okay. 35, the cotangent. So again, you don't have a cotangent button. So it's 1 divided by the tangent of pi over 16. Now, there's no degree symbol. That's radian. Not just because it's a pi, you can have pi degrees if there's a degree symbol. But there's no degree symbol, so that is radians. Put your calculator in radian. Tangent, that's in radian. Like right here, it doesn't have a pi in it, but that's radian because there's no degree symbol. Okay? Be careful. Every other odd. So complete the identity. Sine is 1 over who, tangent 1 over what, secant 1 over what. You can write tangent as sine theta over cosine theta. And then all of these guys right here, we did Big Daddy theorem, sine squared plus cosine squared is sine squared plus cosine squared, Big Daddy theorem equals 1. Okay, 1. And then I took you through a few other identities. This next one, they want you to complete the answer for 1 plus tangent squared. It all starts with the Big Daddy theorem. So if you don't know by heart what the answer is, you can use this answer if this is the one you know and make this one. You want to make tangent squared out of the one that you know by heart. Well, to make tangent, you want sine over cosine. Tangent is sine over cosine. So that means I need to take the sine squared and divide everybody by cosine squared. Because this is tangent, I want sine squared over cosine squared. Everybody gets divided by cosine squared. Sine squared over cosine squared, there's my tangent squared that I'm looking for. Cosine squared divided by cosine squared is a plus 1. 1 over cosine is secant. So 1 over cosine squared is secant squared theta. 1 plus tangent squared plus 1 is the same thing. This is secant squared theta. Now, these other guys, we actually we didn't write it like this. We talked about complementary angles. We did. If this is theta, then this angle has to be 90 degrees minus theta, because they're complementary. Okay. If you know that this one is, 20 degrees, how would you get this? You would go 90 minus the 20, and that would give you your 70-degree answer. You would subtract whatever you start with. That's how you find the missing angle. Okay? So if this one is theta, that's 90 minus the theta in degrees. Okay? If it's in radians, then it's obviously pi over 2 minus theta. So what they're asking right here, if you have degrees, this is 90 minus theta in degrees. If you have the sine of the 90 minus theta, it's equal to, well, the sine of this one is the opposite over the hypotenuse. So in terms of theta, the sine of this angle is the cosine of that angle. Remember me showing you that? Complementary angles. One sine is the other one's cosine. One's cosine is the other one's sine, always. I didn't show it to you with the 90 minus theta and the theta. I showed it to you with P, Q, and R. Okay, we had P, Q, R. The sine of angle P was P over Q. The cosine of angle R was P over Q. One angle's sine is the other one's cosine. So from this perspective, if I make this ABC, the sine of 90 over theta, 90 minus theta, is A over C. And in my triangle, what does A over C represent? Well, A over C for theta, A is the adjacent and C is the hypotenuse. So adjacent over hypotenuse is the cosine for angle theta. The cosine would be the sine. If this is 90 minus theta, the complement is just theta. 90 minus theta and theta are complements. They add up to 90 degrees. Think about it. 90 degrees minus theta plus theta. Oh, those two cancel out. They add up to 90 degrees, the complements of each other. The tangent of one is the cotangent of the other. So the tangent of the complement is the cotangent of the actual angle. So this would be the cotangent of theta. The cotangent of one is the tangent of theta. Okay. Same thing goes for secant and cosecant. If you flip that over, it's just cosine, which means it's going to refer back to the sine of the original theta. So the secant of 90 minus theta is going to be the cosecant of the original theta. I'm trying to get away from having to memorize a whole bunch of things. So we can make a list and you can memorize it, or if you just know the complementary angles, one sine is the other one's cosine, because one's opposite is the other one's adjacent. You know that, you have it all. And then this right here is again, it is just like, they actually give you more information than I do. Because they're giving you specific angles. But the warm-up, if they give you the sine of 60 and the cosine of 60, find these other four answers. If you know one, you know them all. Now it says use the trig identities like sine squared plus cosine squared equals 1. I would just use either if it complements, then use the same thing, or better yet, if you already start to know these things, just put them in. I know tangent 61, the square root 3. Cotangent is going to be the reciprocal, 1 over square root 3. I'm not showing off, it's in there. Okay. The sooner you start to know it, the better. And as again, what I'm going to give you on Monday is this. This is to help. I told you everything is about 0 through 90, because we'll talk about 0 and 90. I'm going to give you this as a chart to help you start filling out. You can use it on quizzes. You can't use it on tests. You can use it on quizzes. And here's everything in degrees, where the answers and radians. And then, can you fill in the blanks? And I'm going to give you a chart that has 3 of them, 3 of those 0 to 90s, and you practice filling them in. Because eventually you're going to take a trig fact quiz, where I'm not going to give you everything. I'm going to give you a mixture of things. You've got to fill in the blanks, like doing math facts when you work in the first grade. But this is how we start. So I'll give that to you on the. All right, we'll take the roll. Everybody's here, all right? Took the roll. Easy one, we'll finish up the rest of practice problems and. Let me stop.